This video is to explain how to use an oxygen bomb calorimeter. This is a bomb calorimeter here. This is actually the bomb head inside, and we'll be explaining how that works. A bomb calorimeter has a charge of something that will be burned in an oxygen atmosphere. We place it inside a calorimeter, which is a bucket of water which sits inside an insulated container, and we measure the temperature before and after combustion, and from that we determine how much energy was released. Now, the first thing we need to do is to actually get the water in there because it needs to be measured precisely. You will need the calorimeter bucket, a dropper, and a jug of, this is actually distilled water. We use distilled not because it needs to be particularly pure, but because the distilled water is sitting in a tank somewhere, and so it's at room temperature. If you use tap water, it'll be cold, and that coming back up to room temperature gives you awkward temperature changes. One thing to notice before the bucket gets filled with water is if you look underneath it, it's got 3 dimples in it, which is where the feet actually stand when it's placed, so it's only got one place to stand inside the insulated jacket, and that circle is a bump inside the bucket, and that is where the actual calorimeter physically sits. The bomb sits on there. You notice it's also made of reflective chromed steel that will reflect as much infrared back into the water as possible rather than radiating it. Let's go and weigh this out now. To weigh this out, you need a high capacity balance. We've only got one of these, and it will weigh up to 6 kilograms. You need exactly 2 kilograms of water. So the first thing to do is put the bucket on and hit the tare button so it goes to 0. And then, first of all, just pour. $19.96, so we're getting there. And add the last bit by dropper, so that you can get to exactly 2000.0. All right, we've now got the appropriate charge in the water bucket for the calorimeter. The actual calorimeter itself is just an insulated jacket. Inside here, we have 3 studs on which this stands, so there's in fact only one way that this fits. And we'll leave that for the moment. Our next task is to actually charge the bomb. The bomb itself is just a stainless steel can with, a ring attachment and the bomb head. Now this is where all the high technology is taking place. This is actually a tablet of about 1 gram of benzoic acid, and we use this to actually calibrate the bomb itself because benzoic acid has a known heat of combustion. I'll show you later how to make the tablet. It sits inside this little combustion cup, which in turn sits on the electrodes. Now, the bomb will actually be fired using fuse wire. We have a whole card of it, and you need approximately that much. So start unwinding it and cut at the next kink, which is about 10 centimeters. But you should actually measure this on the ruler to make sure you know exactly how much you've got, and I've got 9.7 centimeters there. We need to know exactly how much because the fuse will burn, and we know how much energy comes from burning the fuse per centimeter. So, at this point, I now need to wire this in. Wrap it around these electrodes, which will actually provide the electrical charge to ignite the fuse. Put a kink in the middle of it so that it points down, and then take the other end and wrap it around a hook. So The wire is twisted around and is touching, physically touching, the pellet here. You may have one of the newer bomb heads which have holes drilled in the electrode posts and sliding caps above those holes. In this case, you don't need to twist the fuse wire around the electrode post, just thread the wire through the hole like threading a needle. Once you have a short length of wire through the hole, slide the cap down to hold the fuse wire in place. Here we have the pellet in the middle of the cup with the wire physically touching the pellet and the other. What you need not to do is have the wire touching the cup. If you do that, you'll get a short circuit and it won't ignite. It'll just burn out on the side. So this is now more or less ready to go and to be put into the bomb itself. The bomb needs to have some water in it. That's because the oxygen is dry and a combustion product of this is water, and you may have some numerical difficulties if the water evaporates. So you take a couple of droppers of the 2 kilograms that you weighed out into the bucket. Just a couple of squirts, it doesn't matter how much. A couple of squirts of water at the bottom of the bomb. Then if you put this into the high-tech holding bracket, which will hold it firm, take the bomb head, be reasonably careful here, and it fits very snugly into the lid. Push that down with your fingers, and then the locking ring goes on the outside, whoops, and that twists all the way down. Now you do this until it's finger tight. You don't need to be jamming anything, you don't need a wrench for anything, but do it reasonably finger tight. Let me look at these 2 bombs that we're not actually using. There are 4 attachments on this one. These 2 are the electrodes that you will actually be using to fire the bomb itself. We'll have 2 electrical plugs going into that. This is the release knob, so you open and close this to let gas out at the end. And this is the charging input. Now, if you look at the 2 of them, these are slightly different. This is the older one. It has a threaded input. This one has a sliding straight input. So we have 2 separate chargers depending on which bomb head we have. That's the only difference, is just how the oxygen tube attaches. This one here has a threaded attachment, so we'll be using that particular oxygen cylinder. The bomb is a pressure vessel, and pressure vessels can hurt you and do significant damage if they let go. So you need to be quite careful with what you're doing when you are applying pressure to this. This is the discharge valve, and so again, tighten that finger tight, and the oxygen comes from a cylinder like this. At the moment, it is closed off. If you look at this smaller gauge, it is reading 0. That means that it's not attached to the cylinder. When I open this, righty-tighty, lefty-loosey, you'll notice that it goes up to about 2,000 psi inside. You probably won't have to open it. That'll stay open all day, but if it isn't, obviously, that needs to be open. This larger dial is what is happening from here down to the end of this tube. Now the tube attaches onto the threaded inlet, and again, it's finger tight. And I use this handle here to allow air, oxygen rather, into the bomb. You'll see this pressure engage. You may actually hear some clicking noises, which is the valve starting to work. There it was. By letting it in small amounts, I'm not letting it go too far. What I want is 20 atmospheres, which is this has now. The first thing I do is discharge this. We're actually purging the nitrogen atmosphere out of there. So there'll be a noise as I, whoops, yeah, that's tight, and we open the discharge valve. And you'll notice the pressure is dropping. the spitting noise is because there's a little water in the valve. So that has more or less flushed the nitrogen atmosphere that was in there earlier. We tighten this up now and increase this charge is what we will use to actually fire the bomb with. All right, about 20 atmospheres. Now, at this point, we're ready to go, except you will not be able to take this line off because it also has 20 atmospheres in it. So you just push this little handle, and there'll be a hissing noise as we depressurize the line. The bomb is now ready to go. We unscrew the charging hose, and that's now ready. We'll show you the other kind later, the second kind of charging. It's not very different. So we pick this up and go over to the calorimeter now. We're now ready to put the bomb inside the calorimeter. This is a pair of tongs that's specially designed, and it fits into holes in the threaded collar. And they're actually at right angles to these two bumps here. I'm going to lift this and put it into the bomb. If you look, there's a depression, and it actually fits neatly over that circle. The bomb itself will be submerged. Now, there may be a few bubbles coming up, but as long as you don't have a steady stream of bubbles, that's a good thing. This one is working just fine. That is just leaking out of the cap, but steady stream you don't want. So, remove the tongs, if you can. Come on. And shake them off, because you want all of that 2 kilograms of water to remain. Now, while you're still there, these are the electrodes for firing. They go into those 2 electrode depressions. Try not to get your fingers wet at this point. Hold the wire and push down if you can. And take the second one and push it in. If your fingers do perchance get wet, shake them back in. We're now ready to put the lid on. The bomb lid has a holder there, and notice that the bomb was off center. The stirrer goes into the space provided. It fits quite snugly, and there is a stirrer, and it fits with a drive shaft. This needs to be plugged in, and you turn that, and we've now got a stirrer making sure that we've got uniform temperature within the bucket. There are several thermometers available. It's a thermocouple probe, and it just slides down in there like that. Turn the thermometer on. Make sure that you're getting a decent temperature here. Now, this is only giving me 1 decimal place. You want 2 decimal places of degree. So this one is reading 21.46 at the moment. Now, let the bomb sit for about 5 minutes and make sure that you've got a nice steady temperature. When you have got a steady temperature, you'll be ready to fire. And you're firing it using this mechanism here. The wiring has gone. If you look, there are 3 outlets. There is a common electrode, and one for 7 centimeters, the other for 10 centimeters. You're using a 10 centimeter wire, so you wire this in to the 10 centimeter electrode. This is the firing button. This will light up when there is current flowing. When the current flows, it goes through, and it'll burn out almost immediately. So what you want to see when you fire it is for the light to come on and burn out almost immediately. Now, we'll assume this is 21.49. We'll assume we've waited for 5 minutes. You need to be taking notes of time and temperature. Have one of your number with a table preset ready to go at T0, 30 seconds, 60 seconds, 90 seconds, and so on. Ready to fire. Don't put your head over anything, because if it does go, it's going to go straight up. push the button, and we got a light flash, and it disappeared again. So the fuse wire has changed, burned through rather. Now what we do here is watch. It takes about 30 seconds for any temperature to make it through the bomb and into the water. This is starting to increase, so it looks as if we had a successful firing. 21.83. 21.84, 86. So yes, the temperature is increasing. So you record this increasing temperature every 30 seconds till you get a steady point, and it will start to decline. Once it has started to decline, or if you've got a nice steady temperature for 3 or 4 minutes, then you can stop recording. That's probably going to be between 5, 7, maybe 10 minutes before you can stop. This is increasing quite rapidly now. We've now waited long enough that we've got a steady temperature. So remove the thermocouple probe, turn the thermometer off, please. They're battery operated, and turn the stir off. Remove this. Now, it's not vital that you avoid spills at this point, so you get your fingers wet in removing the electrodes. And you can, if you wish, use these, or you can just use your hand to physically lift this out. If you don't want to get wet, be my guest and use the tongs. Place this down, and the first thing to do, of course, is to discharge the pressure. There will be hissing and spitting at this point because there's water. And the first time you do this, everyone in the lab is going to turn around and wonder what the noise is. But after a while, they get used to it. Then once the pressure is equalized, untie my knife and move this out. Now, sometimes this is a little tricky to get out, so if you rock it from side to side, that usually helps it to come out. There we are, and put the head of the bomb in the holder. Now I'm going to hold this up and show it to the camera. This is a good burn, and the thing that's good about it is you don't see anything. It's just some water, some bubbles, and some black stuff. So some little bits that look like black gravel. The small black dots are in fact fuse oxide. The bubbly water is oxygen bubbles in the water itself. What you do not want to see at this point is soot. You sometimes get bomb firings that leave you with black soot lining the container. It looks as if somebody has taken a candle and lined it up with soot. In that case, you didn't have complete combustion and your run is trashed. This one was just fine. The other thing that you need to do is to remove the remains of the fuse wire. There's one, and here's the other, very little on that side. That is a lump of fuse oxide, and in fact there's no wire left on this side. Usually there's two. But straighten out the remaining fuse wire and measure it so that you know how much fuse actually burned by subtracting the leftovers from the initial. The actual heat of combustion of the fuse is given, and so you can then subtract that from the amount of energy that you calculate and realize that the rest of the energy came from the benzoic acid. This is now finished for this run. What you do is just dump this out, dry it out with a paper towel, and then you're ready for the next run. There's a couple of other things that I need to show you, and that is how to prepare the charge and how to pressurize a bomb that has a different oxygen inlet. This is the alternate, in fact, the newer style of charging outlet here, and this is how you use it. Again, turn the valve on the top of the cylinder open if it isn't already. This one's got 1500 psi in it and no pressure coming out. This is a smooth slide-on fitting. Just with the tail moving up, you just push it down firmly like that. As simple as that. Make sure that this valve, the release valve, is tight, and then use this knob to add oxygen into the bomb in the first place. And then for the first one, discharge it. And then you would charge it again. Once you have purged it, you can then charge the bomb properly, ready for firing. And again, get it up to 20 atmospheres. If by mistake you end up with 25 or 30, oops, no problem, just discharge it and we'll move on. This is now ready to fire, and so again I push this lever, which depressurizes the line, and then the brass fitting just slides off. Come on, like that, and this bomb is now ready to fire. Inside the release valve is also a rupture disc. So if for some reason the pressure inside the bomb gets up to about 45, 50 atmospheres, it will blow. It's designed that it will go first rather than having the entire bomb blow, which would be much more damaging. But for that reason, there is an upper limit on the safe pressure in this bomb. We never charge it more than 20 atmospheres. This is a pellet press to make the pellets of solid fuel. The die comes in two parts. Notice this one has a beveled edge and a smooth edge. The bevel goes up top. This is the holder. In one of them it fits all the way down, and the other one it only fits at the top. You want it to go all the way down with the beveled edge up, and you pre-weigh. This is with a top loading balance, about 1 gram of your solid. I'm using benzoic acid here, but you may well be using different solids. Now, not everything goes in, so you'll need to weigh this again later. So let's try getting that in. And this sits on the post like that, and by pulling this handle down, I'm going to compress. And you push that as hard as you can. And frequently that lifts up with it. Then invert this so that you've got the narrower one, and put this, and then just push some more. And that will give you a pellet, which you have compressed. Now, this, as you can see, I didn't get all of the benzoic acid into the pellet. So what you need to do is take this pellet itself and weigh it using an analytical balance, and then you put it into the bomb to be burned. This is how to burn a liquid sample. You take the capsule where the things will be actually burning, and take a cotton ball. You want about half of one of the cotton balls we provide. We know how much cotton gives off when it burns. Put it in there and weigh it analytically so that you know exactly how much cotton is present. Then, also at an analytical balance, take your oil sample and use a dropper to add about 1 gram of oil. Again, using an analytical balance. So you now have an oil-soaked piece of cotton inside the capsule. This then sits in the bomb head, and you apply the wire. And again, the trick is to make sure that the wire is touching the charge, which in this case is the cotton, and not the surface of the metal capsule. When you're doing this, try not to get too much on your fingers because you will remove oil if you are not very careful. However, this is now ready to burn if I had any oil in it as a liquid sample as opposed to a solid sample.